Gentlemen, the last thing I have to give you is your test. Okay?
Oh my God, I told you.
The test is Friday. We are going to, because we have the time, Julian, because we have the time, we're actually going to go over these pretty thoroughly. Okay, so take a moment to look through, see if you have any questions, and then we will go over these as a class, question by question. Okay, so your last test. Overall, so these are actually, it was a tough test.
Josh Fairfax.
No,
it's 81.
oh, that's fun.
I'm an animal. Yes, that's not bad.
Oh, God, it's okay. It's probably like 60.
I got 75.
Oh, yeah.
I thought it did wrong.
And Colin. Okay. Okay, guys, so take a moment and look through your test. See where you have questions.
I knew it. You should have done that.
How much was that for one question?
+5.
That's like 11.
Oh, you're free to question. Each one of those 2 points. 5 points.
Yeah, well,
I know. Multiple choice for word 5. Okay. Solubility problem for each word worth 4 points.
Gogan.
Goggin.
Gogan. Gogan.
I got it.
Gogan. Look at this.
We will go over.
okay.
You have to get one right.
Okay. Guys, are we ready to go over these? Yes? Okay.
I got the double quote.
Okay, gentlemen. Okay, guys, let's bring it together. So let's go over this. We're going to go over this question by question. It's the last test that we will have had. No more IPS tests. Okay, so question 1. So we need to read the graph. How many grams of substance 1 would you expect to find dissolved at 20 degrees Celsius? Okay, how are we going to do this? How did someone solve this? Question 1. Kate, how did you solve question 1?
Okay, so I went to 20 grams.
Yep.
20 degrees.
Yep.
And then I went up and it's up 30. Oh no, it's by margins of 20 on the y-axis. So if it looks about like 35.
Go again, guys. Yes.
It looks like about 35. So
Okay, right. So we're looking at the line for substance 1. Go over to 20 degrees Celsius, come up, and if you look over at the y-axis, it's 35, approximately 35, right? So you would have found about 35 grams, so D. What about 2? What is the lowest temperature at which all of the solid 1 and 2 will dissolve? Matson.
I got E85.
E.
I looked to where the concentration of solutions given is equal to solid and both of them are equal or greater than 85.
Okay. Yep. So any questions on that? E85. Okay. 3. How can you change the solubility of most solids in water? How do you change the solubility? Remember, solubility is a what? Characteristic property. So how are we going to change the solubility of it? Kevin? By raising the temperature of the water. Okay. So 3 is key. What about question 4? It asks, so you have to look at the table. It says, which of these 5 substances may be the same? Go ahead. None of the above, right? None of them actually are similar enough to be the same substance. What about 5? Maria Rosa completely dissolves 2.0 grams of solid in 10 centimeters cubed of water. What is the concentration that she made? So how do I solve for the concentration?
Grams.
Andrew Hart?
Grams per centimeter cube.
Okay, so what do I do to solve for the concentration?
2.0 divided by 10.
2.0 divided by 10 gives me the concentration, but it wants my units in grams per 100 centimeters cubed, right? So times 100. Right, and that would be answer D, letter D. Okay, 6 is a tricky one. I tried to make this very explicit when we were going over this in class, but it asks, which of the following gases is primarily responsible for acid rain? Kevin.
Sulfur dioxide.
It is sulfur dioxide, right? Carbon dioxide is implicated in some ways, right? That's carbonic acid, we talked about that, but it's acid rain is primarily sulfur dioxide. Okay? Question 7. Okay, 4 test tubes, each filled with carbon dioxide, were placed mouth down in beakers of water at different temperatures, right? So this is just like the lab that we did. The test tubes were gently shaken for the same amount of time. So in which beaker or beakers was the water the warmest? So what do we know happens to the solubility of gases in warm water? It goes down. So which would you expect this to be? So if the solubility goes down, is there going to be more water or less water in the tube, the test tube? Right, so what does the water in the test tube represent? Because this comes back.
All about gas dissolved.
The amount of gas dissolved, right? So if it's more soluble, there's going to be more water in the test tube. So if it's less soluble, so if it's the warmest, that means the solubility has decreased. There's going to be less CO2 dissolved. So what's the test tube going to look like? 1. Right. There's going to be less CO2 dissolved. There's going to be less water in the test tube. So 1 and 1 only. Okay. 8. 8 is just like the experiment we did, right? So from these data, we're trying to find the solubility of a solid at room temperature. Okay. How am I going to solve for this? So solubility is what? What's the equation for solubility? Okay, but what is? How do we find solubility? It's what over what?
Oh, mass of solution over volume of solvent.
So it's solute over solvent. Okay, so how do we find the solute?
Solution minus solvent.
The solute? How do we find it?
Mass of addition solution minus mass of addition solvent.
No, that's how we would find the solvent.
Oh.
If we want to find the solute, that is what mass?
Mass addition solid minus mass addition.
Right. So solute will be dish plus solid minus dish, right? Which is just going to give you solid. So dish and solid is 26, minus dish is 23.2, right? Okay, and then how do I find the solvent, Kevin?
Mass of addition solution minus mass of addition solvent.
Yes. So solvent gives you essentially dish plus solution minus dish plus solid, right? So dish and dish cancel out. Solution minus solid gives you solvent. Okay, and that is going to be dish and solution is 34.3 minus 26. So my answer then is E. Okay? Any questions? Okay. Questions 9 and 10 refer to this figure. Okay, so there were actually a lot of questions on 9 and 10. So in all 4 of the test tubes, there's the same volume of water. Okay, so all of these have 20 centimeters cubed. So the first one, 1.5 grams. The second one, 3.0, 4.5, and 6.0. their undissolved solid. Question 9 asks, which tube or tubes definitely contain a saturated solution? Julian?
Which tubes definitely contain a saturated solution?
Yes.
I would say 3 and 4.
Yes, why 3 and 4?
Because they have undissolved solid product.
Correct, right. Because there's undissolved solid, we know that they're saturated solutions. Okay. 10 then asks, what is the concentration of the saturated solution? Richie? B. How did you arrive at B?
It's the only one with two values and has two saturated solutions, so that's the answer.
Okay, so and how did you arrive at 15 to 22.5? Yes, Andrew.
The solubility of 2 is 15 and the solubility of 3 is 22.5. And we're not sure that 2 is saturated or not, so it has to be between that.
Perfect. Yes, okay, that's a great, Richie, is that what you were going to say? Sorry for moving along. Yeah, okay. Right, so the concentration of this we know is 15. The concentration of, we know the ratio right here would be 22.5, so it has to be somewhere between 15 and 22.5 to be a saturated solution. Okay. Moving on. Next one, there's actually a lot of question on number 11 as well. So 3 test tubes were completely filled with gas. It then gives you the solubility of carbon dioxide, ammonia, and hydrogen. Okay? So we know that when they are more soluble, what's going to happen? Julian?
More water in the bottle.
Right, so if there's a higher solubility, there's going to be more water in the bottle. So carbon dioxide is, what do you have for carbon dioxide?
Oh,
Yes, Kevin. C, right? Carbon dioxide is the middle value, and it's also the sort of middle test tube. Okay, what about ammonia? A, yep, the most soluble, and then what about hydrogen?
B.
B, right, the least soluble. Okay, number 12 is a tricky one. So it says beaker A contains a saturated solution of 0.07 grams of carbon dioxide dissolved in 100 centimeters cubed of water. So it's saturated. Carbon dioxide. Beaker B contains a saturated solution of 39 grams of sodium chloride, also in 100 centimeters cubed of water. So it says both solutions are made at 60 degrees Celsius, and if we slowly cool both beakers, what do we think will happen? So important things to note here, guys, both are saturated. Okay? The first one is carbon dioxide. The second one is sodium chloride. Okay, so one second. So when we have a gas, when we cool it, what do we know the solubility of a gas at cooler temperatures? It increases, right? The solubility will increase, so that we expect the carbon dioxide to do what as we cool the test tube? To stay dissolved. Okay. Sodium chloride, however, if it's perfectly saturated, what happens to the solubility of solids when we cool them? It'll decrease. So as we decrease it, what do we think will happen to the sodium chloride? It should come out of solution. Okay. So the answer should be B. Yes, sodium chloride comes out of solution, carbon dioxide stays in solution. Did you have a question on that?
No, I had it.
Bummer. I know I saw you appreciating that one. Bummer. Okay. 13. Okay, 13 guys. This is a lot like our lab as well. 2 groups did the Alka-Seltzer experiment to determine the density of the gas. Okay, group 1 used 10 centimeters cubed of water. Richie. Group 1 used 10 centimeters cubed of water. Group 2 uses 50 centimeters cubed of water. Okay, what do we expect to happen? What is this going to do? How is this going to change our results? Yes?
Group 1 is going to have greater volume because it's less CO2 will get dissolved from the water. So it's going to be a greater volume of gas for group 1.
Yes, so group 1 is going to have a greater volume of
It
gas.
won't affect the density because there's also more mass of the gas going in too.
Exactly. Yes, so the density will stay the same, but group 1 will collect a greater volume of gas. Does that make sense? Because it's proportional. Because we're going to see less of the gas will dissolve in the water, so it'll go out. We'll collect a greater mass of gas versus the mass that will stay dissolved in the solution. Okay, any questions on 13? No, okay, moving on. Question 14. Just like our lab 4.11, the solubility of CO2, it asks, how did team 2 calculate the solubility of CO2? Okay, what do you have?
I had D.
You had D. Okay, how did you get to D?
0.72 times 100 equals 0.14. Wait, no.
D is the correct answer.
I had it down.
Just conceptually, how do we find the solubility? Richie. Kevin.
So you find the mass of the gas dissolved divided by the volume of the bottle.
Yes, exactly. So we have the mass of the gas dissolved, right, which we found using the volume of liquid in the bottle, and then we times it by the density. So we have the mass of gas dissolved, so 0.72, and we divided it over the whole volume of the bottle. Okay, so 0.72 over 525 times 100. Okay, any questions on that? Okay. Why is it not divided over the volume of liquid in the bottle? Okay. Right, and not the whole bottle. Okay. 15. The book value of the solubility of CO2 was 0.17 grams per 100 centimeters cubed. What is the most likely SODD that Team 5 experienced? What can we say about Team 5's data? Yes, Matt.
The volume of the liquid in the bottle is very low.
Okay. Yes, the volume of liquid in the bottle is super low, right? So what is most likely the SODD that they experienced?
A.
A. Okay. They did not swirl their collection bottle enough. Yes.
What about C? I think it wasn't.
C. Okay. I think this is a tricky question because C.
That's
They
they're the same
work.
values. The
No,
the
they're
volume of
not,
the
really
liquid
not.
remaining in the collection bottle is the same as the empty space in the bottle.
No, it's
Because
not.
the volume in the GCB
They're
is the same as the
completely-
volume of water in the
Matt, the
half
volume
soda
of gas in the GCB is 225. Volume of liquid in the GCB is 200. It's not the same.
The collection bottle is the half soda bottle.
What's the upper equal if you do
So
You carry the one.
so the volume of the liquid remaining in the collection bottle. I thought the collection bottle was the soda bottle, right?
Yeah.
So if say say you had, remember how we
Yeah.
put in the same volume?
I think what it's saying is that you switch volume of liquid in bottle and volume of empty space in bottle. That's fine. However, guys, this is a
I didn't have
tricky.
it.
Yeah, it's not C. Just because the question is asking what is the most likely SODD. The most likely SODD is that you just did not swirl your collection bottle enough. C is sort of a tricky answer that they threw in there, but
It was
That's not
The
the
collection bottle,
didn't see,
the
so I got-
collection bottle is
I didn't
not
get
the
half
same
credit
as the
though.
bottle.
Slippery.
That's what I thought it is. That's why I didn't.
okay. Yeah, it wouldn't have been because it's asking you for the most likely SODD. The most likely SODD is that you would have just swirl it.
What do you do?
Why not?
Wait, they gave you two, so like the most likely two SODDs, I guess.
All right, I'm calling your phone.
Yeah, it's not, I'm sorry, it's the most likely SODD. Okay, I know, it's not, they're throwing, again, this, Cleveland headquarters, they did not say it's tricky, but it's asking for the most likely one, the most likely one is that you did not swirl enough. It's not as likely that you would have switched the columns.
I don't think they're saying.
Okay.
Wrong.
Guys, okay, last section, we are not going to do all of these out necessarily, because I would like to give you guys time to move on to the next thing. But if anybody has any questions, they can ask. Yes.
17B.
Okay.
Just
Yeah.
says 25 off, but I don't know why.
Okay, I will get there. So A, guys, is unsaturated. I think everybody got that. B, it should have been about 54-ish. Okay, because when you solve the solubility at 50 degrees Celsius is 85 over 100, you get equals x over 250. Okay, so you have 85 over 100 equals x over 250. X ends up equaling 212. Okay, so for question B, it's 212 minus 159 gives you 53 grams.
Yes.
Okay, if you got something around there, that works too. Question C. Okay, we're going to set this one up. Potassium nitrate at 10 degrees Celsius. Solubility is 23. And that is going to be equal to x over 250. X equals 57.5. Okay, and then 159 over 159 minus 57 gives you 101.5. Okay, the last one, D. Potassium nitrate at question mark x over 100. Okay, x over 100 equals 159 over 250. You end up getting the value of x is 63.6. Okay, do not stop here. Some people use this as the temperature. What does 63.6 represent?
Solubility at the temperature.
Right, so the solubility, so 63.6 over 100, which corresponds to about 39 and 40 degrees Celsius. So 17 then asks you heat a saturated solution originally containing 280 grams of potassium nitrate in 200 milliliters of water. The detail to focus on here is not that we're heating it necessarily, but that some of the volume, some of the water or the solvent is evaporating, okay? So if some of the solvent is evaporating, explain why the mass of potassium nitrate in the beaker does not change. Andrew Hart, why does the mass of potassium nitrate not change?
Because the potassium nitrate is still in the beaker and it will just be super saturated. I got it.
It's not getting
So
Yeah.
It's not getting potassium nitrate is not getting it's still staying in the beaker.
yeah. Right, so if we have a certain amount of potassium nitrate, guys, there's some dissolved in the solution, and there's some that is sitting at the bottom, or it's completely saturated, so there's none sitting at the bottom. But if you remove some of the volume, if some of the solvent is evaporated off, what happens?
There's just
Yes.
more undissolved solid at the bottom.
Yeah, there's just more undissolved solid. Right, it's not, none of the mass of the potassium nitrate is leaving the beaker. So ultimately then, it says, why does the concentration of potassium nitrate dissolved in the water not change, even though the volume decreases? Yes.
The concentration doesn't change because the solubility of potassium nitrate in solution is the same, there's just more undissolved solid.
Right, okay, so the solubility is not changing, the concentration is not changing. What is a sample calculation? Who got the sample calculation correct? What did you have?
I had 20 grams divided by 10 centimeters cubed equals 2 grams versus 10 grams divided by 5 centimeters cubed. 2 grams equals 2 grams.
Okay, yep.
Cell phone.
Head soccer.
What is under?
If I see him, I'll look through.
It's all here.
Okay.
Richie, why is the concentration to the same?
Okay,
Just
Guys,
undissolved solids.
what is the concentration in a saturated solution?
It's the amount of salt, solubility given the volume of salt.
What is the concentration of this saturated solution? No, what is the concentration? Richie, what do you have?
It's 280 over.
Right, it's 280 over 200.
Yeah. And then I said, well, if you just take away half of each, they're still equal.
Right, if we took away half and
I
made
said
this 100,
140 over.
it'd be 140.
And then they're still equal. They're still equal.
And if we made this 50, what would we get? 70. Okay. So this is a sample calculation I was looking for, guys, to show that even when you decrease the volume, the concentration stays exactly the same. Okay? Okay, guys, the extra credit. A was sodium chloride and B was sodium nitrate.